So now we are ready to do a sum. Now the first thing we have to remember about Poisson distribution, we have to look for the word on an average, because that's the indication it's a Poisson distribution, and we have to watch out for the unit, per unit. That's what we have to remember. So when we do a Poisson distribution, we have to remember that step 1 is we have to define the random variable. How do we define it? We define it like this: x equals to number of events that occur per unit. This per unit, if the unit changes from 1 day to 2 day to 3 day, the random variable has to be changed. It's a different thing, it's a different random variable. The next thing that we have to do is define the distribution itself. Defining the distribution means we have to write it like this: what is the value of mean? This is defining the distribution. And of course after this too we can do the probability, and most of the time we have to use the table, not the formula. Now one thing is extremely important: Poisson distribution is a discrete distribution. So discrete distribution means less than 1 means 0, less than 2 means 1 or less than 1, less than 5 means 4, 3, 2, 1, 0, and so on. So that is extremely important. There is separate 1, 2, 3, 4, they're different. So now let's do a sum, a Poisson distribution sum. Now for that, let's scroll down here. Okay, now when we do a Poisson distribution sum, it is important to remember that the presentation actually depends. The maths is very few. It's very simple math. When we talk about math, we're talking about actually calculation. The calculation is very simple. It's all about the concept, what is going on. So the first sum here that we have is a shop sells, shoe shop sells on an average. So we have this on an average, on an average 4 pair of shoes. So we have 4, so that is the mean, and per unit, that is the per unit, per hour. So now the first question A is suggest a suitable distribution for modeling the number of shoes made per hour on a weekday morning and state the value of any parameter. So we know the first thing is it has to be Poisson distribution, because we have on an average, Poisson distribution. The next thing for definition of the distribution is x equals to number of shoes sold, now the unit per hour. Now the definition of the distribution, that is going to be Poisson, and per hour 4 shoes are sold, that's the average, so 4. So that's the parameter, 4 is the parameter. So now the next question says explain why this model might have to be modified for modeling the number of sales made per hour on a Saturday morning. This is actually a question that can be more or less considered to be a common sense question rather than an actual question, because we are talking about weekdays. Weekdays means days that are not holidays, and Saturday is a holiday. So you might say on a Saturday more customers might come, and thus more shoes might be sold. So this is just a question thrown just to check the presence of mind, because it has nothing to do with the distribution or the math. It is something to do with just the common sense. What happens on a holiday? More shoes might be sold. Now the main sum comes, the probability. So the first question that they ask is that more than 4 pair is sold, so probability of x is greater than 4. More than 4 pair is sold. Now one thing now must be talked about, the distribution itself, the table itself. Now this is what a Poisson distribution table look like. In a Poisson distribution table, uh, it has all the probability and it also has all the random variables, so both the probability and the random variable. So this is what the probability distribution look like. Now here, this is lambda. In this table it's given lambda, which means mean, mu. So here the probability are these things. This is the mean given by the lambda, and this is the random variable. So this is actually two blocks, one from 0.5 to 5, which is the value of the mean, and the other from 5.5 to 10. This is the two block sums. So these are the random variables and these are the mean. So whenever you're looking for the probability, you have to look for, first of all, look for the block. Now for our sum, the block is lambda equals to 4. So this is what we're looking for. So this is the block, lambda equals to 4. So since this is the block, we have to find the probability. So this is the block. This is the block. So this, let me mark it out here. This is the block. Now the problem is, this is a cumulative distribution. Cumulative means less than or equal to, meaning total from the beginning. If I say 5, it means 5 or less than 5, total from the beginning. So it's a cumulative distribution. So most of the time the table that is given, it's a cumulative distribution. So although we got the lambda right, we got the mu right, the mean is 4, this is the value going to be. But in our question it said more than 4. So if we look up 4 here, more than 4, it's not going to work. So more than 4, if we make a line here all the way from here, this value that we're going to get, that's not more than 4, that's less than or equal to 4. So we have to make some adjustments here. So let's go back to the sum. Okay, now what we have to do here is somehow we have to find a way of doing the sum as less than. So what can we do here? Well, one of the main thing to remember here is this is discrete. So more than 4 means 5. So if we have more than 4, then we can consider it is 5, 6, 7, 8 and so on. So this is what we want. We want this. But one way of finding this is also less than. So if we take the whole thing and if we removed this portion, then we will get 5, 6, 7, 8 and so on. So more than, x is greater than or equal to 4, x is more than 4 can be written as the total probability is 100%, so we can write 1. So 1 minus probability of x is less than or equal to 4. That means from the entire probability, if you remove 4 or less than 4, this package, whatever is left behind is what you want, more than 4. Remember, in discrete, you have to be careful. If it is important, advisable to write this out here and then do the sum. So now we can go to the table. So the table is going to be, so the table that we have seen before, we have less than 4. So the less than 4 is this. So this one, this is going to be less than or equal to 4, which we already have. So this is 0.6288. So now we have this. So lambda or mu, the mean is 4 and the random variable is x is less than or equals to 4, 0.6288. So if we go back to this, if we go back to our original sum, so it is going to be like this. So we can actually now put the value 1 minus 0.6288 and we can calculate 1 minus 0.6288 to be 0.3712. So that's what we can do. Let's move on to the next one immediately. The next one says no pairs is sold in a half-hour period. Now look here, half hour means the random variable has to be changed because it was previously per hour. So when we do this sum, the first thing we have to write is this is y number of shoes sold per half hour. That means the random variable is going to be a different symbol y, and the value of mu, previously it was 4 for 1 hour, so for half hour it will be half 2. So and the probability we have to find is no, so that means we have to find probability of x is equal to 0. Now x is equal to 0 and x is less than or equal to 0 is the same because nothing lower than 0. So this is going to be found from the table very easily. So if we go back at the table again, then 0 is this one. So if we go here all the way, so it is going to be 0.0183. So let's get back. 0.0183. So that's going to be the probability. So similarly, if we have the final one, more than 4 pairs during each hour from 9 a.m. until noon. 9 a.m. until noon is actually, they're talking about 3 hours. This is every hour for 3 hours. 9 to 10 is 1 hour, 10 to 11 is another hour, 11 to 12 is another hour. So this is 3 consecutive hours, more than 4. So we know this for 1 hour period, more than 4 is this. The probability is 0.3712. So for this particular sum, we can actually do it just by multiplying probability of this hour and probability of that hour and probability of that hour. So it will be probability of greater than 4 and means multiplication in probability. Probability of greater than 4 and probability of greater than 4, meaning for 3 consecutive hours. So this is going to be 0.3712 and 0.3712 and 0.3712. So if we multiply the 3, we'll find the answer, and the answer comes 0.0511. So that's how Poisson distribution is done.